it said the question number is 52. You can check the question paper. The link is given in the description box. So in this question they have said they want to ask which of the statement is false about the normal distribution. Okay. They have given four options. The first is it is applied for discrete random distribution. Second is shape of the normal curve is bell shaped. Area under a standard normal curve is 1. A standard normal curve is symmetric about the value 0. Okay. First, let me draw the normal distribution curve. So this is the normal distribution curve. This point you can see, this point is called z is equals to 0. Okay, this will go to infinity actually. This line will go to infinity and this will go to infinity. If you say the area of this portion, basically it represents the probability. And we used to take the area under this as 1 unit. 1 unit. Because the probability of any possible thing or the probability, the maximum probability or the possibility, it can be 1. Maximum it can be 1. So the area is also 1 under this normal distribution curve. And the shape is like a bell shape. So it's also called bell shaped curve. Bell shaped. It's also called bell shaped curve. So let's see what they are saying in the options. It is applied for a discrete random and they wanted to know which is false. Okay, not true, which is false. So the first statement is it is applied for a discrete random distribution. See, the random distribution is divided into two parts. Okay, random distribution. Random distribution theory in probability is divided into two parts. One is called discrete type, and the other is called continuous type. Okay. In discrete type we have two parts, or it is again divided into two types. One is called binomial and the other is called Poisson distribution. In continuous type you have several parts, but I will name only those which may be required, like one is normal distribution, one is exponential distribution, one is uniform distribution, one is beta distribution, okay. So these are some of the names. I think in industrial also when we deal with part, you used to see this diagram, because you know that in like green in PERT and CPM, the PERT is normal distributed, whereas the activity is beta distributed. So this is the curve for normal distribution. So they have said that it is applied for a discrete random distribution. No, you have seen that it's continuous distribution. Normal comes under continuous distribution, random distribution. So this statement is false. So they wanted to know which statement is false. So this is the possible answer. Okay. Let's check for other options. Shape of the normal curve is bell shape. Yes, it's bell shape. So this option is true. Area under a standard normal curve is 1. As I told you that this curve represents the probability, and the probability, the possible probability, it can be 1. Maximum it can be 1. So the maximum, the area under this is also 1. So this is also true. The standard normal curve is symmetric about the value z is equals to 0. As I said that this point is called z is equals to 0. If you see this is completely symmetric. This is 50%, this is 50% on the left and right. So this is completely symmetric about the value z is equals to 0. So this is also true. So they have asked which is false. So A is the correct answer. But let us look some of the important top points which might you have to know, because they may be asked in coming exams. So let's see what is that. So z is equals to 0, as I said, this is the point. There is one point called, if you move towards the LHS left hand side, it will be negative. Okay, this will go to negative, minus infinity, this goes to plus infinity. Okay, there will be some point, or you can draw one line. This is z is equals to minus 1. You can write z is equals to minus 1. Okay, and similarly on this side, you can write this as z is equals to 1. Similarly on this side, you can again draw one line, and this side also. Yes. So I am naming this as z is equals to minus 2, and this is equals to z is equals to 2. Okay. When you move to almost the end of this point, this is almost z is equals to, this will be z is equals to minus 3. Okay. When you move just to the end of this point, this will be almost z is equals to plus 3. So you need to remember some of the values. Okay. So the area between z is equals to minus 1 so the probability for this event will be 68%. This is approximate value, okay, but you might be required in some of the while solving some of the problems. The area under minus 2 to, when z is minus 2 to 2, so the probability of this event is approximately 95%. And when z is between minus 3 to 3, the probability of event is almost 99.97 or 99.97%. Okay. Let's look some of the important terms. Okay. So what is z? How will you calculate z? So z is equals to, basically it is x minus x bar divided by sigma, where x is any event. Suppose they said that the work need to be completed in 15 days and your mean is 17 days. So 15 minus 17 divided by sigma. Sigma is the standard deviation. Standard deviation. X bar is the mean and x is any variable. Okay. So from this you will get value of z. This Z is only this Z. And if you are writing like this, this will represent one value. Suppose this value is something, maybe K I am representing. This value you will often from one chart is there that is called normal distribution function. This is called normal distribution function. Okay, f of z is called normal distribution function, and there is a special chart for that from where you will get this value. By looking at that chart, you will get this value. So one more thing is there. If you want to find the value of minus z means for this side, it will be simply you can do 1 minus f of z, because you know this curve is completely symmetric. So this is 50% on this side and 50% on this side for this line z is equal to 0. So this is valid. So these are some of the important points which you need to remember. Maybe in industrial also these things are applied. So okay, if you have any queries regarding any portion of this, please mention us in the comment section. We are free to reply to your every queries. So thank you, friends.